Good morning, Mister. This is my project about universal gravitation by Muhammad Abu Samra, grade 9B. Newton gravitational free fall acceleration and the gravitational force, gravitational potential energy, escape speed, Kepler's first law, Kepler's second law, Kepler's third law. Newton's law of gravitation. The apple was attracted to the earth. All boys in the universe were attracted to each other in the same way the apple was attracted to the earth. Newton's law of gravitation. Every particle in the universe attracts every other particle with a force that is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. F equal G M1 M2 over R2. Universal gravitation. G is the constant of universal gravitation. G equals 6.673 times 10 power negative 11 n power 2 and kilogram power 2. This is an example of inverse square law determined experimentally Henry Cavendish in 1798. Universal gravitation. The force that mass 1 exerts on mass 2 is equal to the opposite to the force 2 exerts on mass 1. The force from a Newton's third law action reaction. The gravitational force exerted by a uniform sphere on a particle outside the sphere is the same force exerted by entire mass of the sphere concentrated in the center. Billard A1. This is an example. 0.3 kilogram billiards ball are placed on a table on the corner of right angle. A. Find the net gravitational force on the cue ball. B. Find the compound of the gravitational force of M2 on M3. Kepler's third law. All planets move, Kepler's law. All planets move in elliptical orbits with the sun at one of the focal points. A line drawn from the sun to any planet sweeps from equal areas and equal timelines. The square of orbital period of any planet proportional to cube on the average distance from the sun to the planet. Kepler's first law. All planets move in elliptical orbits with the sun at one focus. Any objects bound to another by an inverse square law will move in an elliptic path. Second focus is empty. Ellipse parameters. Distance A equal AB 2 is the semi-major axis. Distance B equals CD2 is the semi-minor axis. Distance from one focus to the center is EA, where is eccentricity. Eccentricity is 0 for circular orbit and gets larger as the ellipse gets more pronounced. Kepler's second law. A line drawn from the sun to any planet will sweep out equal areas in the equal times. Area A from A to B, C to D are the same. Kepler's third law is the orbital period of any planet in proportional to cube of the average distance from the sun to the planet. T2 equal KA3. T is the period of the planet. A is the average distance from the sun or the length of the semi-major axis for orbit around the sun. K equal KS 2.97 times 10 power negative 19. K is independent of the mass of the planet. K equal 4 theta power 2. 4 by power 2 GM seconds. Done by Muhammad Abu Samra with the supervision of Mr. Isam.